Hello everyone, in this video we're going to talk about equilibrium of a rigid body in 3D. Whenever we are talking about equilibrium, that means the summation of forces is equal to 0. And in case of 3D, we have forces in three directions. Summation of forces in x would be 0, summation of forces in y direction would be 0, and summation of forces in z direction would be 0. So we'll get three equations by writing our summation of forces. Because it's a rigid body, so dimension is not neglected, so summation of moment would be 0. We can write a moment equation about any point, but we usually select a point that there are a couple of forces applied at that point, so make our moment equation simpler. If I use the definition of moment, r cross f, I can say that the summation of r cross f would be 0. That means that if I have two forces that are creating moment about point A, that would be R1 cross F1 plus R2 cross F2 would be 0. And if you have two cross product, you have to do the cross product twice. And the cross product, the first row is ijk, the second row is rx, ry, and rz, fx, fy, and fz. But if we have, let's say our r is 2i and our f is 4j, if I want to find a moment, I do not need to write the whole cross product. I can simply have a cross product between the two. R cross f would be 2i cross 4j. So 2 times 4 would be 8. I cross j would be k. So we can follow this rule that I, j, k, if you're going counterclockwise, it will be positive. That means that I cross j, I'm going counterclockwise, would be positive k. J cross k would be positive I. K cross I would be positive j. And if I go clockwise, if I go k cross j, that would be negative I. J cross I would be negative k, and I cross k would be negative j. So as long as you remember this circle, you can do the cross product. Also, you need to remember that I cross I equals j cross j and k cross k. And all of them would be equal to 0. So if we have our position vector and our force vector in a very simple one component, we really don't need to write the whole cross product equation. And we can use this rule. You just need to remember ijk, counterclockwise, positive. But let's develop this matrix. Let's expand that. We said that this is r cross f, and if I want to write the solution for this, I know I would be ry fz minus rz fy. So here it should be fy. And then I have the j component, which would be rx fz minus rz fx, as well as the k component. The k component would be rx fy minus rv ry fx. So if we are saying that r cross f would be 0, So that's a vector. If a vector is 0, that means that all the components would be 0. That means that the I component would be 0, the j component would be 0, and the z component. What is the I component? That would be mx. So ry fz minus rz fy, that would be our I component. The j component would be our mx, my would be negative rx fz or z fx, and the k component should be 0. That means that mz, all of them are 0, or we should set them to 0 if we have equilibrium. Then we have rx fy minus ry fx. So one thing to pay attention here is that whenever we have when we want to find mx, we only have forces fz and fy. So fx is not going to create a moment about x. Also, we don't have any position vector in the x direction. It's z and y. When we go to y, all we have is x and z. X and z. For z, we have x and y. X and y. So that means that in practice, if we have, let's say this is our coordinate, this is x direction, y direction, and z direction. If we have a force that is parallel to my x direction, that would be fx. That force is not going to create a moment about x-axis. Because we have fx, you don't see any fx in definition here. And also, if there would be a force that is crossing the x-axis, that force is not going to create any moment about x, because there would be rx here, and we don't have any rx in this definition either. So if a force is crossing an axis or is parallel to the axis, it's not going to create any moment about that axis. So that's very important. I'm going to write that. If a force is parallel to an axis or crossing an axis, it will not create any moment about that axis. It might create a moment about other axis, but not about that axis. So either you can use the cross product definition, just write the whole thing, or if it's simple, R and F is pretty simple, you just directly R cross F. Or you can write three equations saying that mx equals 0, my equals 0, and mz. And mx is ryfz minus rzfy. Sometimes these equations, summation of moments about x-axis would be 0, and they are written in a vector form. So ry cross fz plus rz cross fy. So you can see that when I write in a vector form, I use plus instead of minus, because that negative sign will appear when I do the cross product, because I have k component here, that would be cross j, and then k cross j, I'm going clockwise in my circle that I showed here. Therefore, that negative sign will appear. And same thing for summation of moment in y and z. And you can see why I have a negative sign. Let's say this is our x-axis. So I'm going to draw the coordinate again, x, y, and z. So if I have a force Fy, let's say I have Fy here, there is a force in the direction of y, and that force with the x-axis, there is an Rz. That would be Rz. So that force is creating a moment in the opposite direction of x-axis. So it's going to rotate the x-axis around the x-axis, let me draw finger here. So that force is gonna create a motion in this direction. So if you bend your forefinger around x-axis, your thumb would indicate the direction of moment, which is the opposite of x-axis. So you can see a force Fy about x-axis on top of the x-axis is going to create a negative moment about x. And if that force was at the bottom of x-axis, it would have created a positive moment. And that's why these negative signs will appear. But in general, you have 3 equations for forces, and then you have 3 equations for moments. So totally you have 6 equations. And with 6 equations, we can solve for 6 unknowns.